Good evening, everyone. First, welcome everyone to join today's workshop about Introduction to Python for Data Science. So, before we start our workshop, we would like to do some introduction of MLDA. So MLDA is actually a student club under EEE. We are intended to provide an integrated platform for EEE and IEM students to learn and implement machine learning, data science, and AI. And we will also facilitate connections with the industry. So we will also have a lot of interesting workshops in the future. So if you are interested, please follow our social media and stay tuned for our future events. So we actually will have a flagship event, the Deep Learning Week, which is a 1 week long event that aims to promote machine learning and data analytics via industry sharing, recruitment boosts. So if you are interested, you can scan this QR code, or we will send out this tiny URL later for you to join this event. So during the Deep Learning Week, we will actually have a lot of different people from the industry to do sharing with us. And we will also have a lot of workshops as well. So you can see that we have industry partners like A-Star, Shopee, NVIDIA, SG Innovate, and all. So another part of the Deep Learning Week series is a workshop where we are conducting the workshop for all levels of expertise. So our workshop, Introduction to Python, is actually first in the series. So if you are interested, you should follow our social media like MLDA EEE on Instagram, or follow us on LinkedIn. Okay. So my name is Jie, and I will be hosting this workshop with Yonghao. Yonghao, you want to introduce yourself?
Right. Okay. Hello, guys. I'll be taking over the workshop after Jie. So Jie will be going through the general Python commands and the Numpy part, and I'll be going through the Pandas part and the brief introduction to Matplotlib and Seaborn. Yeah. Okay.
Yeah. Okay. So before we start our workshop, I'd like to do some introduction of Python. So Python is actually a very popular programming language. And from this popular programming language rank from GitHub, we can see that Python is actually ranked the first. So if you after this workshop, you will learn some basic knowledge in Python, and which will actually help you a lot if you're interested in this industry and you're interested to do machine learning or data science related stuff or other general programming. So Python is actually built by Guido van Rossum in 1991, and the latest version is Python 3.8.5. It is widely used in developing desktop and web applications and machine learnings. And it's also very easy to read. Okay. So we will share with you a Google Clap link for you to actually try out during our workshop as well. So Yonghao, can you share with them the link?
Yeah.
Okay, yeah. Thank you. So I encourage everyone to try out in this Google Clap file while you are taking the workshop. So you can put them in split screens so you can watch the workshop and also try things on your own, because we believe that the best way to learn programming is to actually have some hands-on experience. Yeah. So when you go to the Google Clap, you have to make a copy in your Google Drive so you can modify it and change things as well. Okay, I will give you guys about 2 minutes to do the setup. Yeah, so the link is already shared by Yonghao in the Zoom chat. Okay. Okay, let's just start. So first of all, I will cover the Python basic syntax. Then first of all, I like to cover indentation. So indentation is a very important part in Python. Like in other programming language, I believe if you have knowledge in other programming language, you may notice that there's also indentation. But in other programming language, the indentation is more for readability. While in Python, the indentation is very important. So the interpreter will actually read your code according to the indentation to decide which code blocks are like together and which code blocks are on different levels. So you can take a look at the first case here. We have an if statement. Then you can see that both lines are indented to the right. So they are actually considered as the same block of code. So if this is true, both of these will be executed. Okay. It will take a while for the things to initialize. Yeah, so you can see that in this case, both of the codes are executed. So they are actually under the same block in this. Then we can look at the second example where this line is actually outside of this indentation. So they won't be considered inside the same like group as this code. So in this case, we know that 5 is not less than 2. So we know that this code won't run. So the only code that will be run will be this line. Yeah, so if we put indentation in this line, then we'll notice that actually nothing will be printed out. So in Python, you need to be careful of the indentation. It's not part of the style. It is also part of the logic of Python. Then after that, we will talk about comments. So in Python, we use comments as in like other programming language. We use comments to annotate codes. So comments are ignored by the Python interpreters. So the comments are actually used for readability. So for people read their codes, they can actually understand what each line of code is for. So for a single line comment, we'll use this hex sign. Then for multi-line comment, we will use 3 double quotations at the start and at the end. Yeah, so these comments will be just ignored by the interpreter. They won't be run by the machine. It's just for your like info. Then we will go to the Python variables and data types. So in Python, a variable is created when assigned with a value. Then we use an equal sign to assign a value to a variable. And if you have knowledge in other programming language, you will notice that in Python, you don't have to declare data type because Python is a dynamic typed programming language. So the data type is actually determined at runtime. So in this case, we will cover about like integer. So in this case, we assign 10 to this A. So when we do assignment, we give the variable a name, then we assign to a value. So when the code is executed at runtime, it will actually automatically determine the type is an integer. So this is integer type, and this is a floating point type, which is a float. So the difference between floating point and integer is that they have a decimal point. Yeah. Then we will also have string, and string is enclosed by a pair of a single or double quotation marks. So like for this case, we have a hello world string, and so you have to be careful that when you declare a string, you must have the either a single quotation or double quotation, and you have to be consistent. So if you use a single quotation at the start, you should also use a single quotation at the end. So yeah, then the Python interpreter will actually automatically determines the type is a string. Then after that, we will have list. So list is a collections of items, and the items are ordered. And also we will allow like mixed data types. So in this case, a D is a list of 3 different strings. So they are strings because they are enclosed by double quotation marks. And when you declare a list, you have to use this brackets and use a comma to separate different objects or different items inside the list as well. And we will talk about more about lists in later chapters. Then we will also have a tuple. Tuple is looks almost the same as the list. The difference is that a tuple is immutable. So basically means that when you create a tuple, you cannot reassign the individual values or delete the individual values in the tuple. So you declare a tuple by this brackets. We will also have a range. So for range, it will actually create a series of iterables, which we will also cover in the later chapters. So you declare a range by calling range and giving a starting index and end index. And if the starting index is 0, you can actually omit the 0. So you can just call it range 10 in this case. Then next will be dictionary. So dictionary, it's basically holds a key value pairs, and it's also an unordered data collections. We access the values using the keys. So in this case, this from part will be the keys, and this will be the value. Then we use this to separate the key and value, and use a comma to separate like different items. If you want to access the like John, you actually have to call for the key, which will be the name. So in this case, when you try this, you will actually get the value of John. So you can also try out to see how you can get the value of 36. Then we will have set. Set is also a collection of data. Then the difference between set and list is that for set, it has no duplicate values. Individual items are unique and they are unordered. So set, we won't really cover much about set. So if you are interested, you can like do some research after this workshop. After that, we have a frozen set. So frozen set is similar to set. The only difference is that for a frozen set, you cannot like make changes to the set after you do declarations. And the last data type we'll cover is Boolean. So Boolean is it only has 2 possible values, true and false. So you just declare it by assign a value true or false to it. You can use a not to inverse the value of a Boolean. So in this case, J is a Boolean. Then you can also print the value of J. Then it will show you false because it's supposed to be true at first, but then we use a not to reverse it. Then next we will cover about the basic operations in Python. First, we will start with the arithmetic operations. So in Python, we will have plus, minus, times, division, modular, exponential, and floor divisions. So I think for the plus, minus, multiplication, division, and modular, it's just the same as like others as well. It's just the same as in other programming language. And then for this double quotation, for this double multiplication sign, it actually means a exponential. So this actually means the x to the power of y. Then for the floor division, the main difference between this and this single division is that this one will always return as an integer value, because you can try to run this code and you will see that for this 10 divided by 3, it will actually return as a floating point. But for this floor division, it will return as the floor value. So the floor value basically means that you discard the decimal parts of the float, then it will just return you like 3. Then after this, we will have plus equal, minus equal, times equal, divide equal, modular equal, and floor division equal. So for this x plus equal, it basically means that x equals to x plus y. So we actually do a addition for the y value to the x, then we assign this new value to the x. So these two are actually means the same thing. It's just different ways of presentation. So you can choose either way you want. So the same logic applies to like minus equal, times equal, divide equal, modular equal, and floor division equal. So after all these operations, x will actually be assigned with a new value. Then after that, we will have comparison operations. So for comparisons, we have comparators, we will have equal, more than, less than, not equal. So in Python, we use double equal signs to represent, to check for the equality. And all these comparators will actually return as a Boolean value. So the value will be either true or false. So in this case, you can see that x is not equals to y. So if we as if x is equals to y, it will return as false. So you can try to change the values here of x and y. So actually in Python, you can also do something like this. Like you can just assign multiple variables together in the same line. So this one will be assigned to x, and this 2 will be assigned to y.
Yeah.
You can also like separate them by different lines. It's really just up to you. Okay. Then after that, we will have in and not in. So this is to check for the memberships. So for in and not in, we can actually check whether a certain element is inside another list, tuple, set, or even strings. So for this case, we have a list of fruits. We have apple and banana. So we can actually check if banana is inside X. So if it's yes, then it will return as true. Otherwise, it will return as false. So we can do this for list. We can also do this for a string. So we can check whether a substring is inside the string. So you can also try out with this. Like you can try to change a value here, and you will see that it will return as like different values. So you can do some changes to the code and see if the output is what you expected. Then after that, we will go into more details about list. So as we mentioned before, list is an ordered collection of data, and we use index to access, reassign, and delete the items. So by ordered, we don't mean that the values inside list are sorted. It just means that they actually have an index number to corresponding to the elements. So like this case, they will actually have a unique index number corresponding to each element, and we can just access them by calling the index number, or do reassignment, or even do deletion. So we will first declare a list. It will have 3 elements: apple, banana, and cherry. Then if we want to access the elements, we just have to call the index number. So in this case, and the important thing to know is that for list, the index actually starting from 0. So the first element is actually indexed at index 0. So you have to really keep note of this. So if we want to access the first element inside this list, we actually have to call D0. So you can also try to change this to 1, then you will actually return as a second element. So when you want to call access the elements inside list, first you need to know the index, and you also have to make sure that the index is inside the list. So in this case, we only have 3 elements, so the index will be 0, 1, and 2. So if we want to print out D3, it will actually return as an error because this index is out of the range. As for this list, the index is only from 0 to 2. Then for list, we also have negative index. We can also access element by negative indexing. So from this diagram, you can actually see how the negative index works. So -1 basically means the last element, and -2 means the second last element, so on and so forth. Yeah, so this is a bit different from this index is from 0. So, but this for negative index, the last element is actually -1. So you have to take note of this when you use them. So if we want to access the last element inside the list, we actually have to call for D-1. And it will return us cherry, which is the last element. We can also get a sublist of a list by slicing them. So let's say we have this very long list that has 1, 2, 3, 4, 5, 6, 7 elements, and we want to get a sublist from index 2 to index 5. So one thing to take note of is that this sub-index function, range function will actually include the starting index, but it will exclude the last index element. So for this case, it will only return us items at index number 2, 3, and 4. So the number 5 is actually not included. So you can see that in this output, it only have 3 elements, which is at index 2, 3, and 4. So the last index is actually excluded. So if you want to actually have this melon, then you need to make sure that the last index is the last item you want index +1. We can also use the negative indexing to get the sublist as well. So yeah, then they will actually return us the first item from behind to the last item from behind. And the last item will not be included. That's why this only return us 3 elements: orange, kiwi, and melon. So we can also reassign the values inside the list by using their index number. So in this case, if we want to change the second object, banana, to a kiwi, we just need to call for the list name, then the index number, and we'll just use the equal sign to do the reassignment. Then you will see that the new list is actually, the items banana is actually replaced by kiwi. And how do we add items to a list? So a list is it's mutable, so we can actually make changes after we declare them. So we can add new items by append. So in this case, we will actually append a new orange string to this list. So if we print out the results, you can see that the new list now contains 4 objects. We can also add an item at a specific index. So in this case, we will use insert. First with the index number we want to insert it to, second with the element we want to insert to. So this will actually insert at index number 1, so which will be in front of which will be here. So everything behind this will actually be shift right. You can see that now the orange is inserted into the list and also at the specific index 1 here, so which will makes it becomes the second element. Then all the elements here, banana and cherry, will just automatically shift right. Next, we can also loop through the list. Like we can loop through all the items inside list by using a for loop. So this is how the syntax is like for X in this list. So this list is the list we want to iterate through, and the X is actually a temporary name for all the elements that we get out. So we can just change it to anything like fruit. Then if we want to use this fruit, we'll actually have to use it in the later. So when we print out, we actually have to refer it as a fruit. So the fruit actually means the every element we iterate through this list. Then we can also check if some items exist inside the list, as we mentioned before when we talk about the in and not in. So we basically use this in keyword to check if certain element is inside the list. So in this case, if the apple is inside this list, we'll print out this word. So yeah. Then after that, we can also get to know the length of the list by using this function len. Then after the brackets will be the name of the list. So you can see that it has 3 items inside the list, so the length will be 3. Then we can also concatenate 2 lists together by using the plus keyword. So in this case, the 2 lists will actually be appended together. So this 4, 5, 6 will append to this 1, 2, 3. Then we will have a new list of those 2 lists together. Then we also have some other native functions for lists in Python. First, we have maxima and min. So we can use the maxima and max and min functions to actually get out the item with a maximum value and the item with a minimum value. So this works for like strings or numeric values as well. So for strings, the maximum will be according to the alphabetic order. So the alphabets in the like Z, which is the last alphabet, will actually have the highest value. So that's why in this case, Zara is the maximum in this list. So now we also have the min function, which returns the minimal value item from this list. Then for list, we will also have a sort function. So the sort function basically does the sorting for the list. And by default, it will sort this by ascending order. So this one will return as a list from the smallest value to the biggest. Then for the sort value, we can also do a reverse sort. So we do so by insert a reverse equals to true. So this one will actually return as a sorted list by descending order. So the highest value element will in the front and the least will be at the behind. We can also pass in a function to the list start. So let's say for this case, we want to sort out this like cars list. We want to do so by sorting according to the length of the value. So we can just declare a function. Then we're passing a function as a key to this sort. So in this case, we will actually sort the list according to the length of the value. So you can see that the shortest string will actually appears in the front of the list. Then you can also do reverse for this as well. Then if we have a quite complicated list, you can also do something like this. We're passing a function, then we want to sort the list by the year value inside, like this value here. So this is actually a list of dictionaries. Then we can do so by passing like this function. So you will actually sort the list by this like different years. So in this case, you can see that it will do the work for you. So actually sort and all other native functions in Python, they are quite powerful. You can just use them for a lot of like different cases as well. Then we will go through our first exercise, which will be to find the common elements in this list A and list B. So I will give you guys about 5 minutes time. Then we will share with you the solutions. So if you have any questions, you can actually send in the chat and let us know. Then we will assign you with a helper to a breakout Zoom. So you can ask the helper for like help in specific codes or anything. You will have 2 minutes more. And then we will share the solution with you guys. Okay. So I will share our solution here. And it's okay if we don't have the same solutions. As long as you get the same output, then it's all right. Yeah, so in Python, we have many different ways to approach the same thing. And there's no right or wrong solutions as long as your solution makes sense. And so this is one of the solutions we have. Okay, then we will move on to the control flow. So then the first control flow I mentioned will be the conditional expressions. We actually covered some of them just now. So the conditional expressions will just be done by if and else. So sometimes we may have to like check for certain conditions, and if this condition is true, we will like do something. So like in this case, if B is more than A, we will print out like B is greater than A. And we know that in this case it's not true. So this one will not be executed. So this block of code will only be executed if this condition is true. So if we change this statement and we say, you'll actually find that this line of code will be executed because now this condition is true. So if we have multiple conditions, we can use if, else if, and else. Or you can just have like if else. So I'll revert this back. Okay, so in this case, this is not true, so this line of code will not be run. So the else will be true, so this line of code will be run. Then if we have like more than two conditions, we can actually make use of if, else if, and else. So the else will be run if all these are not true. And then in this case, you can see that only this line of code will be wrong because only this condition is true. So you can actually change the values of A and B and try to run the code, and you will see they may have different outputs as well. Then for if-else statement, we actually have like a shorthand ways. So if we only have an if condition, we can actually put them in one line instead of like just now we have like two lines of code. Then we also have a shorthand form for if and else. So it looks a bit different from this, as this one is just we move them to the same line. But for this one, it's a bit different. So the logic is that we will print A if this is true. If this is not true, we will print B. So in this case, it will print B because we can see that A is 2, B is 330. So A more than B will return as a false. So it will run the else code, which will be print B. Yeah, so in actual like practical codes, you can use like this default form or you can use a shorthand form. It's all your personal choice. Then after that, we will have indefinite iteration, which will be done by the while loop. So for a while loop, if this condition is true, then all of the codes inside here will be run until this is false. So we can see that at first i's value is 1, so it's like less than 6 until it reaches 6, then this condition will not be true anymore, so it won't be run anymore. Or we can look at this example. Else print. Yeah, so for while loop, we can also have a else. So basically this code will run after this while condition, because after this is like not true anymore, we'll go to the else and run this code. So the else part is actually optional. You can have it, or if you don't need, then you can just have this while loop. So when you're using a while loop, make sure that for this condition checking, you will always like update the conditions inside the while loop. Let's say if we remove this line, then you will realize that the I will always be 1. So we will have a infinity loop of printing of ones, and this is not what we intended as well. So when we use a while loop, make sure that you always update the conditions so you won't get into a infinity loop. Then we will also have for loops. So for for loops, we mostly use it to iterate through like lists, or strings, like we mentioned just now, or we can also use them for like tuple, range, set, or frozen set. Yeah. So for this for loop, we will actually iterate through all the elements, and yeah, it will print out all the elements in this case. And you can also do the same thing for the string. So every characters inside the string will be printed out. And just now we mentioned about range, and we talked about that the 6 won't be included as well. So for this range, it actually means range from 0 to 6, and it will return as like 0 to 5. So in Python, most of the case when you see this like range or index, if it has a starting index and an end index, then the end index will not be included most of the time. Like just now how in the list, the last index is not included as well. Then now we will also have a short like exercise about list as well. About you can use like list and other control flows we learned to do these short questions. So basically we are given this like a short list, and we want to output the number of even numbers and odd numbers. So you just need to print out the like even numbers and odd numbers. It will be given like 5 minutes as well. Then after that, we will share with you our solutions. You can also have like multiple solutions as well. Okay, I think I have like 2 more minutes. Okay, so I will share with you our solutions. So yeah, so basically for this case, we just iterate through all the elements inside the numbers by using a for loop. Then we do a check if not modular 2. So this basically means that x modulo 2 will actually return us a value is either 1 or 0. So if it's 0, then the not 0 actually, so actually in Python, the Boolean can also be like represented by 0 and 1. So 0 means false and 1 means true. So in this case, if this returns 0, basically means that this is a even number. So this will actually return, if it's an even number, it will return as 0. So if we do not, it will inverse the value and becomes true. So we will have an even count plus equal to 1. So we'll add 1 to the even count. Else we will add 1 to the odd count. Then in the end, it will return us like the number of even numbers and odd numbers. Okay, so after that, we will go to functions. So for functions is basically just a name block codes that we can reuse in the later. So for this like block of codes, we give it a name. So you use a def, a keyword to show that this is a starting of a function. Then this will be the function name. And then inside brackets, you will have the parameters. In this case, in this function, we don't need any parameters. So we just leave it blank. And you call a function by calling the function name and the brackets as well. So in this case, we'll call for this function and we'll do the print hello from a function for us. So if we do this multiple times, we'll actually do the print multiple times as well. So we use functions because we may want to like reuse some of the codes later part, and we don't want to actually like rewrite a lot of like the codes again. So in this case, we will have a function with parameters. So for function declarations for the parameters, you also don't have to declare the data type as well, like how we declare a variable. So in this case, we will declare a function called add. Then we have two parameters, a and b. Then we'll actually result the value of a plus b. Then we call the function by calling the name of the function, brackets, and with parameters. So this 2 will actually be the a, then 5 will be the b. Then this will return us 7 as well. Yeah. So for functions, we can have like multiple functions. We can have multiple parameters or 0 parameters. It's all up to you. Then after that, we will have lambda functions. So a lambda function is similar to a function. It's just that it's an anonymous function. So it doesn't have a name. Like in this one, this function is called my function. This function is called x. For a lambda function, it does not have a name. And we use a lambda function when the function itself is only required for a short period of time. Like in this case, we have a function lambda a. So a will be the parameter. Then what we return will be a plus 10. So we assign this like function actually to a variable x. So in Python, we can assign values to variables. We can also assign like functions to variables as well. So now we assign these lambda functions and we call it by x. Then we can just do print x, then the parameter 5. So it will return us a 10 because it will return us like 5 plus 10. So it will return us 15. Then for lambda functions, we can also have like multiple parameters as well. So in this case, we'll have 3 parameters. Then this lambda function will actually return us the sum of all the 3 values. So in this case, we have 5, 6, and 2. Then it will return us 13. So the output is 13. So you can like, maybe you can also change this to plus sign. So the function will actually return us the multiplications of all the values as well. Yeah, so which will be 60. After that, we will have map and filters. So map and filters are used to do some manipulations in creating a list. So we always normally use lambda functions inside the map and filter. And so imagine we have a list of numbers 1 to 5, and we want to get a new list where the new list array element is the square of the numbers inside this items list. So a normal way we can do this is by using a for loop. Then we iterate through all the elements. Then we do the square of each element. Then we append them to this list. Then in the end, we print out this list. So we can print out and see the value inside. So for map, actually we can do the same thing in one line. We can just call a map and we just apply a function. So map basically applies a function to all the elements in an input list. In this case, we make items as an input list, and for all the item inside the items list, we apply a lambda function. So this is actually a use of lambda functions. We only need this for inside this map functions. Then you can see that it actually generates the same results, but now we only have one line of code comparing with this 3 line of codes. So a filter is actually similar to map. The difference is that you will create a list of elements for which a function returns true. So we can use this to filter out some numbers inside a list and to a new list as well. So in this case, we have a number list. It's actually creating by this range. So it will return us a value from -5 to 4. Then we want to get all the negative values. We can just apply a filter function. Then inside the filter function, this will be the input list, and we'll apply for a lambda function that if this is true, if this condition is true, then it will be going inside this less than 0 list. Otherwise, it will not. So you can see that it will actually filter out all the negative numbers and put them inside a new list. Another way to do the same thing as map and filter is actually called list comprehension. So list comprehension provides a concise way to create list. Then we can actually see that how the list comprehension is different. So still the same case just now, we want to have a squares list of this original number list. So this is the first way people might come up with. Then in list comprehension, we can actually just do it like this. So the list comprehension syntax will be like this. A new list will be this expression. This basically means a function will apply to the array element inside this list. Then this and this will be the conditions, and for loop 1 or more. And so we will have a loop and the conditions. So in this case, we will iterate through the numbers, and for all array number, we will do this exponential to the power of 2 and put them inside this squares list. So yeah, this actually generates the same results as this one. Then it's the difference is that this is much more shorter. So you can use for loop or map or list comprehension to achieve the same thing. Then we can also, okay, so next we will come to our exercise. So just now for the list exercise, we have a exercise to actually find the common numbers in both list A and list B. So now you should try to use list comprehension to rewrite this code. And after that, you will actually notice the difference between you will actually realize that at least comprehension can do the same thing as this, and in very short code, in very short line of code as well. So I will give you guys like 5 minutes. And if you have any questions and anything you want to ask, please write in the chat. Then I will assign you to a helper in a breakout room to help you. Okay. So I'll share with you the solutions by us. Yay. So you can actually just rewrite all this like long, like 1, 2, 3, 5 lines into this single line, and it will actually do the same thing. So I think in practice, you actually comprehension more, and it will help you to write concise code. Then this will be all for the Python basic syntax. Then after that will be going to like NumPy. So let's go to the introduction of NumPy first. So NumPy is actually a Python library used for working with arrays. Then it also has functions for like working domain of linear algebra, Fourier transform, and matrices. It was created in 2005 by Travis Oliphant. It's an open source project and you can use it freely. So NumPy actually stands for numerical Python and it's basically used for like arrays, matrices. Okay, then let's go back to the code. Okay, so when we use a NumPy library, since it's an external library, we actually have to do an import. So we have to do import NumPy, and we can rename it by as keyword. So we can name it as NP. So I think when you, since in Google Colab, actually all the like most popular libraries will actually be pre-installed. So we only have to do import. But if you are running the code on your local machine also, you probably have to install the NumPy libraries and do all the setups first before you can actually use this import NumPy as NP. So a NumPy, first, how to create a NumPy array. So you create a NumPy array by using the np.array. So when you want to use a function in NumPy, you actually have to call np, which is like or NumPy if you don't do the rename, then then the functions inside the NumPy. So in this way, the interpreters will know that you are calling a function from this library. So you create a NumPy array by passing a list to the NumPy array. And you can, sorry, I haven't done importation. Yeah, so if you don't import the NumPy library, they will actually return you an error because they don't really recognize what is this NP or array. Yeah, then after that, you can see the type of this array is actually a NumPy ND array. So ND means n-dimensional. So in NumPy array, we can actually work with more than one dimensional. Then array index slicing max and min. So for this part, it's actually quite similar to the list in Python. The main difference is the way we call for the functions. So for the max and min, we actually have to do np.amax, amin, then passing the array, then they will actually return as a maximal and minimal. So you also access the values by calling the index. So array 0 will be the first index, which will be 1. Then we can do the same thing for n-dimensional array as well. So in this case, we have a 2-dimensional array consists of this and this. So if we want to access a second element in the first dimension, so in n-dimensional array, if we want to access certain elements, we actually have to first give the dimensional index, then second is the element index. So in this case, this will be the first like dimension, and second element will be this number 2. So you can try out change the index numbers here, and try to like access like different elements inside this 2-dimensional array. You can also like slicing the list, so like create a sub array from this as well. So in this case, right, we're passing this 1, which will be the dimensional index. So the 1 will be like the second dimensional, which will be from this onwards. So this basically means that everything after we will get from the second element and everything after. So you can see in this case, we'll just return as the second element and the third element. Then we can also do like something like this. We can access the columns and rows by using a syntax. So the first one will be the row or the dimension, and the second will be the column. So in this case, we want to access the elements. put out everything inside the second column, we actually have to put the index here. Then the first one we just like leave blank. We'll just return as everything inside the second column. Then if we want to get everything from the second row, so the row will be the first like index number, and the second row, the index number will be 1. So you will return as the second row, which will be like this whole thing. Okay. Then we can also if we want to access a specific elements, we can call the row number and the column number. So in this case, we want the third row and third element. So third row will be this one, then the third element will be this one. So it will return as 6. And we can also slice everything from a column 1 onwards. So in this case, the row we will just like leave blank. Then after that, we will just also leave it blank. So it will basically means that all the elements in this. So you can try to change all these index numbers here to try out these functions. And we can also do array search in NumPy. So the keyword will be where. So we use a where function, then inside we're passing a condition for the where function. So in this case, we want to find the elements 4. So you will actually return as an array, because in this case, we will have like 1, 2, 3, 3 fours in this array. So you will return the index number of the elements. So this will be 0, 1, 2, 3, 4, 5, 6. So the answer will be 3 and 5 and 6. And we also have the array sort as well. We have for the list, but it's just the syntax is different. So we call the sort by np.sort. Then we pass in the NumPy array. Then after that, we will have broadcast. So broadcast basically means sometimes in like when you do do manipulation with n-dimensional arrays, they may be of like different sizes. So the broadcast will actually trying to broadcast, like the broadcast actually means that they will expand the elements to be of the same size. So you can actually do the manipulation. So in this one, we have a 3-dimensional array, and this is like a 1-dimensional array. Then we want to do, after we broadcast, we can actually do a addition of them. So in this case, this X array will actually be expanded. So it will be expanded to like 1, 1, 1, 2, 2, 2, 3, 3, 3. So you will then this 4, 5, 6 will also be expanded vertically to 4, 5, 6, 4, 5, 6, 4, 5, 6. So you can see the result is actually like the addition of such like arrays as well. Then after that, we will have join. So we can also concatenate to a NumPy arrays in NumPy, but the syntax is different. In this case, we will use np.concatenate. Then we will just join these two NumPy array together. Then we can also have a split. So for a split, it can actually split this like NumPy array into, in this case, 3 arrays of the same size. So you can see that this array will be split into 3 parts, 1, 2, 3, 4, and 5, 6. We can also do a reshape of the array. So in this case, we want to reshape this 1-dimensional array to this 3 by 4 by 3 matrix. So you can see that the end results will be something like this. So this 4 will be the dimension, then this 3 will be like the size of the in each dimension as well. Then we will have universal functions in NumPy. In NumPy, we can actually do manipulation between with two NumPy array. Like we can, this plus sign will actually add each numbers each elements together. So in this case, we'll actually return as a new NumPy array with 1 plus 4, 2 plus 5, 3 plus 6, and 4 plus 7. So we can actually apply like plus, minus. For minus, we'll actually do the same thing. 10 minus 20, 11 minus 21, so on and so forth. Then we can also have like multiplication. So the each element will just be multiplied to the element with the same index number in the second like NumPy array. Then we can also do the division. So this is quite useful. And we can also have exponential. This is quite useful when you have like two NumPy arrays and you want to do some manipulation with them. So in this way, you don't have to like do a for loop or so to loop through the element in array 1. Then you do the calculation with the elements in array 2. You can just use these universal functions to do the thing for you, and it will be much more faster, and you only need to write like single line of code instead of like having loops to do that. Then just now we also mentioned that the NumPy is also used for matrix, so we can actually do matrix multiplications in NumPy as well. So in this case, we have two 3 by 3 matrix, and we can just do the multiplication by calling this function np dot dot. So it will return as a dot product of like this two matrices. Okay, so that will be all for NumPy. Then we will have a exercise to convert the values of this temperatures in Fahrenheit into like centigrade degrees. Oh, sorry, this value is actually in centigrades. Then we want to convert the value into Fahrenheit. So you can try to use the universal functions and to do the manipulation to this array. And I will give you guys about 5 minutes as well. And after that, I will share with you the solutions we had. And if you have any questions, you can just raise in the chat. So I will assign you as a helper into the breakout room. Okay, I think time's up. I will show you the solutions we have. So you can actually just have this. Oh, okay. So, yeah, you can just have this one single line of code to actually do this thing for you. Yeah. So that's all for the Python syntax and NumPy. Then we'll pass on to you how to talk about pandas and other like data visualization libraries.
Thanks, Jay. Okay, so I'll continue with pandas. Okay, so just a quick introduction to pandas. So pandas is a Python data analysis library. It's built on the NumPy package, which is introduced by Jay just now. And the key data structure for pandas is called the data frame. Okay, so data frame is just like an Excel table. You can store and manipulate tabular data in a data frame. And just a fun fact about pandas. So yeah, the creator is called Wes McKinney, and the name pandas is actually derived from the term panel data, which is a common term for multi-dimensional data sets encountered in statistics and econometrics. Okay, so yeah. All right. So yeah. Hang on, I think I'm lagging a bit on this. Okay, so when we are dealing with pandas, a lot of the times we will be importing data sets. And one way to do so is to mount your whole Google Drive, personal drive into Google Colab. And so this code will allow you to do that. So yeah, you can actually just mount your whole drive. Yeah, so you prompt you to a URL and you get your authorization code there. Okay, yeah, so you just copy the code and you go back and enter your authorization code and you press Shift Enter. Okay, so you show you that it's mounted, and after that you can actually check your files and you can see that there's a drive. So this is actually all your stuff. Okay, so yeah. All right, so we'll start with series. So series is a very common data type in Pandas. So it's actually just yeah, it's like a list, but then like a NumPy array, yeah. But then it can have labels. Okay, so before that we have to import pandas as a library into your notebook, just like NumPy. So yeah, in this case we import both of them because we'll be using both of them. Okay, so first off, creating a series. So you can actually create a series of many types of data structures. So lists, NumPy arrays, dictionaries, yeah, all of them. So these are just a few examples of creating a series. So the command is just pd.series. And then there's two parameters, is data and index. Okay, so if you don't specify anything on the index parameter, it will just come out as a series of numbers from 0. Then yeah, so these are just a few ways to convert all your various data structures into a series. And yeah, built-in functions can be converted into a series as well. Okay, and yeah, after that, after you have a series, we'll see how you deal with the index of a series. Okay, so I'll first create two series. Yeah, so this is series 1 and this is series 2. Okay, so yeah, how do you retrieve the data from a series? Like how do you get the number 1 in a row named Jack? Okay, so there's a few ways to do that. So first we will just refer to the name of the index label. So let's say you want to get 1, then we refer to the series 1. This is the series 1, and you put in the name of the label, the row that you want, of the data that you want. Okay, so you can either do a series 1, then square brackets and the name, or series 1.log. It's like a location. Okay, so yeah, you get 1. If you don't want to refer to the name of the label, you can also refer to the numerical label of the index. So in this case, the 0th row is a numbered 0. So yeah, and the ilog is actually has the same function, just that it's a numerical index location. Yeah. Okay, so after that, you say that, oh, maybe I want to get the jack instead. I don't want the number 1, I want the name jack. So what, because this is actually the index object, an index list. So what you have to do, you have to call the first series, and you call the index, and you call the first item of the index. In this case, you get jack. Okay, so if you change it to the second one, like the number 1 actually represents the second row, you actually get Jill. Okay, so yeah, you can also perform simple operations. So you see that series 1 and series 2 have actually the exact same indexes. And when you do a series 1 plus series 2, you just simply add up the numbers in both series and give you a resultant series. Okay, after series, we'll have data frames. So data frames is actually just a bunch of series bundled together into like a table. So how do you create a pandas data frame? You do pd.dataframe. Okay, so yeah, so in these curly brackets, you put the name of the column, and then a list. So this list will actually be presented in the table below. Yeah, in this case, I assign it to df. So when you call df again, you will just see the resultant data frame. Yeah, so this is the data frame. Okay, so yeah, after that, we'll be going through how to read in data sets. So in many cases, you'll be reading in external data set instead of creating your own data frames. So yeah, there's a few to do that. And yeah, for reading in CSV files, comma separated values file, we'll be doing a demonstration with the Titanic data set. And you can actually just get the CSV file from this link. So you just click on it and then you can click download. Okay, after you download it into a local drive, you can execute this line of code to actually initiate the upload command. And then you can choose files from your local drive. Okay, so yeah, in this case, you can take the Titanic data set. Okay, so after that, you'll see it in your content folder. Yeah, Titanic data set is just there. And then you can just do a read in. This is the reading syntax. And then you know that it's in a content file. And this is the name of the file. Okay. Yeah, and it will just show you the whole data. Okay, so this is just another way. So you can just import IO and then you just replace this as your file name. Like it will just show you your recently uploaded file. Okay, I will give you the same thing. Okay, so aside from CSV file, Pandas can also read in Excel file. So yeah, same thing. This will be the link to get you the Excel file. And yeah, we'll just actually do the same thing. Yeah. And yeah, this is how you can get your external data into your notebook and use it. Okay, so yeah, you see that this data set is actually quite large, like the Titanic one. Yeah, there's so many rows, right? So sometimes you just want to get a summary of what the data is about, and the following 3 syntaxes will give you some information about the data set. So one is the Titanic.head. So notice that I actually assign my Titanic data set to Titanic. So after that, I can just say Titanic, then I call the head function. Then it will give me the first 5 rows. Okay. If you change it to 10, yeah, you can actually just modify how many rows that you want as the first few rows of the data set. So yeah, just to give you some info. Okay, .describe will actually give you some basic data like count, mean how many data, what is the average, what's the quartiles, what's the minimum and maximum values in the columns. And Titanic.info will actually show you exactly how many rows are there, what's the type of the data at a particular column, and what are the columns that actually have missing data, like this one. So you see that the normal value is 891, and in the age column, there's actually only 714 a bit real non-null data. That means like over 100 data actually null values. Okay, so yeah, we'll be dealing with that later. So for now, we'll be doing with selection. So notice that data frames are Give me a second, guys. Okay, sorry guys. I think these two cells will be missing from your copy of code as well. I think you have to reload the file to see these two cells. But basically, these two cells are just creating a sample data frame for me to demonstrate the following functions. Okay, so yeah, so you see that it's just creating a 5 times 4 table with some random numbers, and I assign it to a DF. So after that, you see that maybe I want to select just the Y column, or I want to select just W and Y column from this whole data. I don't want to use the whole data frame. So what I can do is, yeah, just type DF and put in your name of the column in the square brackets. And notice that if you want to select more than one column, you have to put them in another square brackets before putting them in the larger square brackets. Okay, yeah, so okay. After that, you can select a row. And to select a row, it's actually, notice that this command is actually very similar to what we do with a series. So you can choose the dot log and you can select the row labeled A. Okay, and yeah. So after that, you can do some numerical index location as well. So notice that the one before the comma is actually for the rows, and the ones after the commas are actually for the columns. So okay, if you don't specify anything for the first one, it actually just get all the columns. Okay, so yeah. But if you specify something, let's say you do a 0 to 2, you actually just get a first and second row, and you just get a 2 times 2 table. Yeah, it's a bit different. All right, so after that, we'll be going through a selection based on criteria. Okay, I hope you guys can get these two codes for the data frame. Yeah, very sorry for the technical difficulties in the notebook. Okay, so selection based on criteria. Okay, so it actually give you a Boolean. So you know that this will give you a return a true or false. So when you put this into the data frame, okay, let's just show you what it does. Okay, so when you do a DF larger than 0, you actually show a true or false. So you know that the true ones are those that have values larger than 0, and those that are false will have values less than 0. And when you pass that into a data frame, it will give you those that are larger than 0 only. The rest will be written as null values. Okay, so the rest will be done on a specific column. So let's say this one, I'm performing it on a W column. And yeah. So you check on the W column that the values are larger than 0. Okay, so actually if you do this, yeah, you show that on the W column, only A and D are true. So when I return this, right, to a data frame, they actually just give me an A and B rows of the whole data frame. Okay. So yeah, the following is just selection on another sub data frame. So you can just take this as a data frame, then you pass in the column that you want. So it actually just give you, yeah, these two of the Y column. Okay, yeah, the same thing applies. And yeah, this is just extensive criteria. So the and the or in Python. And remember that you have to put the brackets for each of your statements. And yeah, you actually just get what you need. Okay, for Boolean selection criteria. And after that, it's creating a new row. Actually, yeah, just this is actually a new. This is actually a new column. Okay, so yeah. Okay, so when you want to create a new column, it can be as simple as df assigning a new column name and then assigning some simple operations. So if you don't want to assign operations to existing columns, you can actually do a list. So you just pass a list into this variable and pass it back to df. You actually get a new column like this. Right. So yeah, after that we'll go through how to drop a column. So when you want to drop a column, you need to specify axis equals to 1. And if you want to drop a row, you have to specify axis equals to 0. Okay. Okay, some of you might realize that why is it that when I drop a column here, it appears back in the following cell? Okay. This is because I'm not implementing in place equals to false, in place equals to true. So in all these cases, it's actually just copying the original data frame, just removing it. But in actual fact, it's actually not removing it from the actual data frame. So what we do is we put it in place equals to true. Okay. Then, yeah, you see that. Okay, so when you call df again, you see that the new column will not be there anymore. Okay, and after you drop and after you perform this, you will not see the new column. Okay, so yeah, this is what the in place function do. Then this parameter actually appears in a few of the pandas commands. So yeah, you need to make sure that you have to set it to true if you really want to remove it permanently. Okay, so after that, there's indexing as well. So this is just a few indexing functions. So let's say I use the previous data frame and I reset the index. Okay, so what this does is that it will just remove the previous index of A, B, C, D, E, and just replace with 0, 1, 2, 3, 4. And then you bring the index to a new column. Okay, this is what reset index does. Okay, notice that this one also has a in place. Okay, so yeah, in this case, I won't permanently change this. So okay, when I call df again, I actually just get df. Okay, so what I want to do here is that I want to implement a new type of index. Okay, so this is what my index will look like, and I'll just assign it to a temporary column called df type. Okay, so when I call df, I actually get a type column with this type of stuff, and then I can use df.setIndex to bring this column as my new index. Okay, yeah, so this is what it will look like. Okay, so this is how you deal with indexes. After that, we'll go through how to deal with missing data. So in a lot of the data sets that you get, there might be a lot of missing values, and you have to deal with it. If not, you can't use it for your machine learning stuff and all that. Okay, so yeah, this is just a sample data frame. Okay, so in this sample data frame, there's actually 3 missing values. So what you can do is that you can check for is null. So what it does is that you return true if it's null, and you return false if it's not null. Okay, so this is just for you to see. Yeah, so actually it's a 0 and 1 value. So let's say if I do So what you can do here is that you can actually check how many null values are there. And in this case, there's only one. Okay, so because there's only one true value, the rest returns 0. Okay, so this is how you can check how many null values are there in a column. All right, so that okay, so dealing with null data, so there's a few options. You can either just drop that with drop NA. In this case, you drop all the rows. And if you put x is equals to 1, you drop all the columns. Yeah. Okay, so apart from that, you can actually specify a threshold. So the threshold will be a baseline of how many non-null values must be there before you need to drop them. Okay, so if I specify threshold equals to 2, I will still get 2 rows. Okay, because in the second row, there's actually still 2 non-null values. Okay, so if I put this into 3, I'll actually just get the one row with no null values at all. So yeah, this is the threshold. Okay, so if you don't want to drop them, you can actually just fill them with something else. So in this case, it's fill NA. And if you want to fill it all with zeros, you just put fill NA 0. Or if you want to fill it with something else, so this is some aggregate functions that you can use in Pandas. So let's say I want to fill all the null values in the A column with the mean of the A column. Okay, just a refresh. Yeah, this is the df2. Okay, so the mean value will be just 1.5. Yeah, so I'll get 1.5. Okay, if you want to fill with the sum, you can do so as well. You will get 3. Or you want to fill with the standard deviation, sorry. Yeah. Okay. Then group by. Okay, so group by is actually some way that you can actually process data frame just by some categorical labels in a certain column. Okay, so what you can do here, yeah. Okay, in this case, you ought to upload another set of data, and you can just get them directly through this link that we've prepped here. And we'll go through the same procedure again, upload, choose your file. So yeah, so you can see this. So this is actually quite a big file because there's actually 20,000 rows. Right. So yeah, if you want to group it by the ocean proximity, notice that the ocean proximity is the one with the categorical labels. So you can actually just do a housing.group by. And in this case, I assign it to a variable. So yeah. So what I can show you is that the type of the group is actually some pandas group by object. Okay, so yeah, you can do a lot of functions with this group by data set. So what it does is that it just computes some aggregate functions based on the group by categories that you have done. So there's a lot of functions, and I'll just do a few examples here, and you can get the rest from this link. Okay, so yeah, let's say I want a mean of the latitude. So you compute the mean of the latitude for each of these categories. Okay, the count, like the frequency of each of these categories, the latitude, or the variance in the latitude column for each of these categories. So yeah, this is what it does. Okay, so group by lets you do some categorized analysis of data. Okay, so the same thing, you can do some describe to get some information about each of these categories. So yeah, you actually do some very detailed analysis, I guess. Okay, so after that, we'll go through combining data frames. So combining data frames is useful when you have like 2 data sets and you want to combine them into one single data set. Okay, so I'll talk about 2 ways. So they are concatenate and merge. So for concatenate, it will just be simply combining through indexes or just through columns. So I'll demonstrate this by actually getting some subsets from the housing data set. Okay, And yeah. Okay, so these are just like smaller data sets from the housing data set, so you can see how concatenation works. So yeah, this is the syntax, and you just put all the data sets that you want to combine in a list, and you do a pd.concat. Okay, notice that by default you concatenate by rows. So notice that you just match the columns and then just match by just continue on the indexes, and you see that the three of them are actually combined into a single data frame. Okay, so but if you concatenate them by columns and you specify x is equals to 1, you actually get a lot of NaN values. Okay, why is that so? Because the indexes are actually not the same. In this case, they just combine by the columns. Notice that the columns are actually just joined to each other. And yeah, you get a lot of NaN values. And normally you won't do this. And okay, so but okay, just to show you what it actually does. So okay, so if I create another a new set of data set 3 that actually has indexes 0, 1, 2, 3, and 4, you get a different thing in the sense that you see that the third data set is actually combined back with the first data set here because the index actually match and they can actually just join by columns. Okay, so after that there's merge. So merge is a concatenation, but it concatenates, it joins with a common, like you need to specify joining on a specific column. Okay, so I'll just get two sets of data. Okay, this is some data sets. Okay, so this is just something from the housing data, and this is like some code, some labeling ID for each proximity that I actually want to join it back to the data frame. Okay, so I want to join this to this, okay, and make them into a single data frame. So what I can do is a pd.merge, and you see that this is the first data set, this is the second data set. Okay, this is the parameters, right? So, okay, how you want to join them, there's a few ways: inner, outer, left and right. Left and right will be hard to demonstrate in this situation, and I'll just demonstrate, I'll just explain what is inner and outer. So in the case of inner, you'll be using intersection, and in the case of outer, you'll be using a union. So in this case, both of our data sets have actually all the keys because we are actually joining on ocean proximity. Actually, do they have all the keys? Maybe not. Okay, so you see that when you merge, right, intersection, yeah, you just get the labeling into this one. Okay, so okay, when you do a union, okay, you see that you get the island as well. In this case, there's nothing there on the main data set. So yeah, intersection will get only the keys that are common to both data sets, while union will actually get all of the keys, okay, whether they are common rows or not. Okay, so yeah, you can feel free to experiment with right and left as well. It's for other situations that's not really common. Okay, so after that, we have dealing with unique values. Okay, so sometimes you have to want to find out how many unique values are there or what are unique values in a column. Okay, so in this case, this is the sample data frame. And let's say you want to find out how many unique persons are there, like how many unique salespersons are there. So you can just do a column, like column selection, and just type a dot unique. And yeah, in this case, there's just 4 different people. And if you want to see what is the number of the unique people, okay, you get 4. And you can also do a value count, which will actually count the number of each unique label in the column. So in this case, you will get this. All right, so after that, we'll be dealing with date time data. So yeah, this will be particularly important when you're dealing with some e-commerce data that has a time lock onto a column, something like that. So what you do is okay, convert all the strings. Like normally when you load a data set, they have dates in the form of strings. And if you don't convert them into some proper datetime objects, you won't be able to perform operations with them. So what we do here is we can convert some strings into some proper datetime format. And note that Pandas actually have their own datetime library, like it's actually incorporated, so you don't have to use the Python datetime library to do your Pandas datetime conversions. Okay, so this is how you can just convert a string into a datetime object. Okay, so the format parameter is actually optional, but I will demonstrate later that you actually make it faster. Okay, so if you check the type of this thing, it's actually some timestamp object of Pandas. All right, so okay, after that we'll go through some operations with datetime, and these two syntax will actually create a list of dates with a frequency. It's a fixed frequency. So in this case, we fix the frequency as days, and we create 11 more values. So this is actually our base value, and we create 11 more values in a list. This is the list. Okay, this does the same thing as the previous one, just some different syntax. Okay, after that, we can actually assign this to a data frame column by just putting this list into the column. And we can get the first 5 rows by doing the F5 of it. And you will see this, okay. Okay, so after that, you can actually do some date offset, which is actually just how you add some, add or minus a period of time to your initial date time. Okay, in this case, you'll get a whole next week column, which actually like 1 week after the initial date. Okay, PD.date offset. Okay, another one, a very common operation is just to calculate difference in time between two timestamp objects. So let's say you just want to calculate the difference in time between the first one and the zeroth row. And what we actually get is some time delta object. Okay, so in this case, I'll just assign it to time elapsed. Okay, so yeah, you see that time elapsed is actually a time delta object, and you can actually call some functions out of this time delta object. Like let's say 1 the days, they'll just give you 1 day. Or you can type the total seconds. You actually get the total seconds of 1 day. Yeah, right. And if you just want the number of hours, you can do that as well. Let's see. Yeah, 24 hours. So yeah, you can actually perform some manipulation, and you actually get what you want to extract from this time stamp object. Okay, so after that, we'll go through some extra info from datetime. So yeah, if you want the year, the month, the day, the hour, the minute, the weekday, the day name, or even the day of the year. Okay, so this will just actually do it for you. Yeah, I'll just put it in columns so it'll be easier for you to see what it does. After that, there's applying functions. Okay. Yeah. So recall that we can apply functions we can write a function in Python. And what we can actually do is we can apply this function to a column and bring a new column that is the result of the function from this column. So let's say I want to do a power function. Okay, and you return x multiplied by x. Okay, so it's just x squared. Okay, so what I need to do is I need to type temdf, the column, and I need to put a dot apply, and then my function name. Okay, then you get a new column. Okay, so yeah, so this is just some basic function applications, but then we'll show how to apply functions faster with Pandas, because yeah, you can actually just loop with Pandas because it will actually take a very long time. So I actually take this example from this website. Is some website that actually gives a good explanation of what Pandas does. Okay, so yeah, basically we'll be solving a problem, and we'll see how fast you can solve a problem with different types of functions. Okay, basically these functions are performing the same operations. Okay, so first off, we have to check off the time tariff rate. So what we need to do is perform the same thing here, and I'll explain the question. Okay, so what you do here is that we have to assign, we have to calculate the cost for this hour in terms of energy usage. This is the time range where it will be assigned a cents per kilowatt hour. This is the energy in kilowatt hours, and this is the starting hour. Okay, so let's say it's 0, and then in these terms, we should actually assign a 12 cents per kilowatt hour for the 0th hour, and so on and so forth. Okay, and we have to do it for the whole table. So first off, you have to convert the date time, and here I'll show you what's the difference between assigning a format and actually not assigning a format when you convert date time. Okay, so actually here I'll import a timing function, and this is just some code to actually run the function for 10 times and get the average runtime for the code. Okay, so in this case, you notice that this function doesn't have a format specified, and this function has a format specified. Okay, it will actually be a difference of a few seconds, but it will be quite significant when you scale it up. Yeah. Okay, so yeah, if can always specify the format if you know how to do it. And there's actually, I specify a link on top if you want to check out what are the different alphabets for different types of components of a date. And yeah, you can actually just specify your format of the date before you pass in the function. Okay, now we'll get back to the real question of assigning this cents cost per energy kilowatt hour. Okay, so this is what I need to do. Okay, assigning rates based on the hour range. Okay, this is the basic function. And after that, we'll apply this function. Okay, so this is a complex function here, but then what this is using is a for loop, okay? And it's looping through and checking the energy kilowatt hour at the date time columns, getting the hours, passing this back into this apply tariff function, and then append them into this list. And after that, assigning them to a new column. Okay, so essentially this is just a normal looping, and normal looping actually takes a very long time. Okay, so I'll just go through another one first because it'll take some time here. And yeah, when you use iter rows, it's actually essentially looping as well, but then iter rows is actually a Pandas built-in looping function. So it'll be a bit faster, but it's still very slow. Okay. And then after that, you can see that the third one actually just goes through the specified columns that they want. Okay, so in this case, we just want to go through this one by columns, and we apply it using a Lambda function. Okay, so we check the row, get this one, assign them back to a new column. Okay, so this will actually be much faster. Yeah, you can see that this has a runtime of 3 seconds, 0.9 seconds, and 0.2 seconds. Okay, and then the functions below are actually those that actually don't use looping. Okay, so they actually do the function as a whole. So to demonstrate this function, the first thing that you need to do is you have to set the index, set the date time column as the index first, so you can do some labeling and binning afterwards. So what this essentially does is it actually returns some Boolean values according to the range of the index. Because now the index is it's actually the date time already. So as you can see here. Okay, so place equals to true. Yes. I haven't run this. Yeah, you can see that in this case, the index is the date time. So what they can do is they actually just return some Boolean values based on their ranges. And after that, you just go through this one, check if it's true. If it's true, then you return 28 or 20 or 19. So it's actually avoiding some looping. You see that it's much faster. Okay. Okay, so in the other case, it's actually some binning function. So in this case, it's just cutting the index into a few bins. And if it's between 0 and 6, so this is inclusive of 0 because the include lowest is true. Okay, so this will be the first bin, this will be the second bin, and this will be the third bin. Okay, and it will just make everything as int, the labeling, so that you can just pass this back into a function and you multiply by the energy per kilowatt hour and you will get the cost. Okay, so yeah, you can see that this is very fast. So essentially, okay, so I'll just show yeah. Yeah, this kind of weird, but yeah. Okay, so after this, it'll just be a pandas exercise already. So yeah, to do this exercise, you'll actually be using the Titanic data set. So we actually uploaded it already, but yeah, just to show you again, we'll just upload this again. You can actually just get it directly from this link here. Okay. And yeah, so the questions below, okay, there's actually 7 questions for you all to try out. And question 6 and question 7 requires some knowledge of strings. Question 6 requires some knowledge on strings, and question 7 requires some knowledge on just some more extensive applications. So yeah, you all can try this out. I'll give this exercise can be done in like 15 minutes, I guess. So yeah, we'll be back at 9:15. All right. Now we'll continue with the exercises. Okay. So yeah. Okay, so the first question is, what is the average fare of all the passengers? Okay, so what you do is just go to Titanic, passengers. Sorry, what's the average fare there? Yeah, so the average fare, and then just type .me. Okay, so this is the average fare. Okay, so after that you have to find what is the average fare of passengers with the first class tickets. Okay, so what you have to do is you must go to Titanic and filter out the ones with the tickets class with 1. Okay, after that, you can go through the fair and find the mean. Okay. Okay, so next, how many unique ticket numbers are there? Okay, so the way to do that is just use the n unique. Okay, so actually, so the Titanic tickets n unique. Okay, so after that, what are the cabin numbers? Okay, so this is just value counts output. Okay, so the way they do that is just to go to Titanic cabin and dot value counts. Okay. In this case, I just want the first 3 rows because these 3 rows shows the cabin numbers with the most number of passengers. So I can do is this. Okay. So after that, we have to find the number of passengers that have siblings or spouses or parents or children on board. Okay. So to do that, we have to first go to Titanic. Okay, then we have to put in our criteria. Okay, so the criteria is Titanic okay, this one is larger than 0, or the Titanic is larger than 0. Okay, and you have to remember to put it in the brackets. Okay, so when you pass this, okay, you get the data set, but then you want a number. Okay, so to get a number, you just pass the whole thing through a line. You get it. Okay, so afterward, you have to find the age of the passenger that has the word cap in his name. So what you have to do for this one is actually just go through Titanic and name, and you have to do some string manipulation here, where you do a string dot contains and you check for cap. Okay, so this is what you want to filter out. Okay, that means that you have to go to Titanic and you pass this whole thing into the data frame. Okay, so you get this row. Okay, after that you have to find the age. Okay, what you get is this one, but then in this term, in this question, we just want the number. So to get the number, we have to go to .ilog and go 0. Okay, this will get us the number 70. Okay, because remember that the 745 is usually the index, so this will just give us the direct value. Okay, so for this one, you have to find the age group that has the highest number of survivors out of these 3 provided. So, okay, this is not the only solution. There's many solutions to this problem. So, this is just one of them. And the way that we do that is you have to define a simple function first. We classify them into different bins. Okay, so which is less than or equals to 20. Okay, so this is the basic function that we're implementing. Okay, so after that, I'll pass this into a data frame function. Okay. Okay, so you use a lambda function. Passing the function name. And we just get the row. So that's the age. Okay. Specify axis equals to 1. Okay. Then after that, we'll apply this function to our data frame, which is Titanic. Oops. Okay, so after applying, okay, you'll be able to see that there's a new column. And then what I have to do is I have to extract it out by doing a group by function. Okay, so I assign them to some temporary data frame first, and I do a dot group by. Okay, then I get the survived, and I get a number of survivors by using dot count. Yeah. Okay. So after that, I have to extract out 0 to 20 to 50 because I know that this is the one with the highest survivors. Okay, so what I do is I do a temp equals to temp.max, which will actually give me the highest number, the one with the highest number of survivors. Okay, then I'll do a dot index 0. Okay, so this is how we get to answer. All right, so that's it for pandas. Okay, so now we'll go through Matplotlib and Seaborn. Okay, so Matplotlib and Seaborn are both just simple data visualization libraries in Python. Okay, so this is just a basic comparison table between Matplotlib and Seaborn. Okay, so Matplotlib is mainly deployed for basic plotting, and Seaborn has actually more visualization patterns in terms of decoration purposes, okay, and colors. Okay, and Matplotlib has some resemblance to MATLAB. So if you've used MATLAB before, Matplotlib is actually quite similar. And for Seaborn, it's more integrated for working with pandas and their frames. Okay, so dive back in. Okay, so the same thing, you have to import a library first because Matplotlib is installed but it's not imported, and you cannot use it if you don't import it. Okay, then this line of code is actually just for you to show the plots, especially when you're using Jupyter notebooks. Okay, after that, we'll be showing the data. Okay, this is the sample data for you to plot it. Okay, and you have the basic plotting. Okay, so what you do here is this is just a very simple code. Okay, so remember that we have imported as plt matplotlib.pyplot. So here we just have to do the plot command and have x data, y data, and the color of the plot. Okay, then your x label, your y label, and the title of your plot, and then plot.show. Okay, so this is what you will get. Okay, so this is actually customizable where you can put a red and you will get another color of the plot. All right. And okay, after that, you can also create multi-plots on the same canvas. Okay, so this is in essence creating two plots on the same space. Okay, so what it does is you have to specify your subplots. Like let's say you want the one row and two columns, and then you have to specify the index of the plot. So the first one has these parameters, and the second one has these parameters. All right. So okay, so these are the basic plotting. So what we will go through now is some object-oriented methods of plotting. So by using object-oriented methods, it will give you more control over your graphs. All right. So this look at it in a while, and what you do is you instantiate a figure object by calling plot of figure and assigning it to a fig, and then you can add your axis for plotting. Okay, these parameters left, bottom, width, and height will be useful when we go through multiple plottings on the same canvas. Right, so yeah, you can see that it's actually the exact same thing, just that you are now using axis, and the commands are different where you're actually calling attributes from this object itself. Okay, so yeah, after that we'll go through this one. So I'll just run it for you all to see what's the final sample. So in this case, you'll notice that we are still instantiating an figure object, and then we have the two axes. That means two plots. Okay, after that, this will be useful where this second axis will determine the position of the second smaller plot. Okay, so specifying this to 0.1 and 0.2, where it's the left and the bottom, we actually put it here. Okay, so you can play around with this and you can change it. You can see that it actually changes position. Okay, so this will become useful when you're doing with multiple plots in the same space. Okay, the rest of them are just the same plotting commands. Right. This is actually tuple unpacking. So what it does is that it just actually uses one single command to create two objects. So you don't have to do more instantiations like the one on the top. So after that, you just plot it on the axis, which is the same thing as well. Okay, after that, you can do some for loop if you want to plot multiple canvases of some iterable functions. Okay, so this will instantiate the axis for plotting, and this is the for loop for plotting. And you can see the figure. Right. Okay, after that, okay, this is just some command for some optimizing. Okay, so you can see that in this case, the axis labels are actually overlapping with another plot. So what you can do is put in a plot.type layout after your code, and it'll be plotted neatly on the same canvas. Okay, so after that, this is just for you to adjust the figure size. Okay, yeah, this is just a side note. All right, after that, you can add labels and legends to your plots. Okay, so notice that this is actually the axis, it's the same thing. Okay, and in this case, you put in another parameter called the label. Okay, and you call axis.legend, and you will get this. Okay, so after that, you can position your legend. Okay, 1, 2, 3, 4 represents the 4 different corners, and if you put 0, you will let Matplotlib decide on the optimal location. I'll show you if I comment this out. And you see that it actually be at the lower right corner. Okay, leaving it to Matplotlib, you bring it to the you bring it to the top left corner. Right. Okay, after that, this is just some more commands. Okay, where in this case, let me just run the code first. Okay. So for tight axis, it will actually just show you the plotting canvas where there's graphs, and custom axis range will actually set the x limit and the y limit. Okay, so in tight axis, it will not be much changes because this graph is actually quite optimized already in terms of space. And for custom axis range, I actually set it to 1 to 2 and from 2 to 4. So you see a magnified version of the graph. Yeah. Okay, so that's it for Matplotlib. Yeah, this is just some simple basic commands. Okay, so after that, we have Seaborn. Okay, so I'll introduce two types of plots for Seaborn. So the distribution plots and the categorical plots. Okay, so for the distribution plots, okay, so first off, we have to import the libraries first. Yeah, the same thing, Seaborn, and import it as an SNS. Okay, and we code Matplotlib inline. Okay, so to show you the plottings with Seaborn, we'll be using some data set from the default library of Seaborn. So we'll be using tips for our demonstration, but then you can check out all the other data sets from this link. Okay. Yeah, so this is the data set. Okay. You don't have to upload anything, you just have to code this syntax. All right, the first one is this plot. Okay. So this plot combines 3 different plots: the histogram, the KD, which is the kernel density estimate, and the RUG plot. Okay, setting all true will bring all 3 into the same plot. Okay, the bins is customizable. If you don't put bins parameter, you will have a default bin optimized to your graph. All right, so I'll just do this. Okay, so changing the bins will actually change the look of the graph, and changing something to false will actually just make it missing. Okay, so if you don't put bins, it's actually also, the code will work as well. Yeah, just that it will just optimize for you. Okay, so this is this plot. Okay, after that you have the join plot. So what join plot does is that you can actually just select 2 specific data that you want to plot against each other. In this case, we'll be plotting the total bill against the tip. All right, and then we can just plot it total bill against tip. Okay, scatter. In this case, it's scatter, but if you change this into the other stuff, let's say it's a hex, you can see that it's actually different. Yeah, I think the darker colors are the ones with the more data points. Yeah, and you can see that there's a KDE illustration at the sides as well. Okay, so yeah, you can see that Seaborn generally has a better visualization. And after that, we have the pair plot. Okay, when you do pair plot, it actually plots all the numerical data in the data set. So as long as it's a numerical data, you plot it against each other. So you notice that the size, the tips, and the total bill are actually the only columns with numerical data in this data set. Okay, size, tip, and total bill. That's why they are all used to plot against each other in pair plot. Right. Okay. After that, there's categorical plots. Okay. For categorical plots, we start out with count plot and bar plot. So count plot is just a simple frequency. Okay, let's say we want to set plot the gender, use the data tips. This is what you get. And for bar plot, you can actually implement functions. Okay, so the default estimator is actually the main function. So let's say you want the gender against the total bill. You actually plot you can actually get the mean of the total bill. Okay, it's actually not the frequency. Okay, and you see that there's an estimated parameter. You can implement some different Numpy functions, like let's say. Yes, and yeah, standard deviation or whatnot is as the function. Okay, so yeah, after that we'll be introducing box plot and violin plot. Yeah. So box and violin plots are actually quite similar to each other, where they show you the quartiles, like what's the third quartile, first quartile, and the median, the outside points. And the difference between these two is just the violin plot has an extra KDE plot at the side. Okay, so this is the difference. And yeah, you can actually just plot it with the SNS.plot box plot command and the SNS.violin plot command. Your data, your x-axis data, your y-axis data, your data, the variable that you have assigned, and the color scheme. Okay, so yeah, you notice that there's actually a lot of parameters you can actually explore, and it can actually bring very good visualization to your graph plotting. Okay, notice that in this case, there's also a hue where you can actually just split the plot into two for smokers, yes, smokers or non-smokers. Yeah, so this is actually highly customizable. You can explore on the documentations of the various parameters that they have for Seaborn. Okay, Violin plot is just about the same. It's just that they have another kernel density estimate plot at the side. Okay, and you can specify your color scheme. All right, so I guess that's it for the workshop today. Thank you if you are still if you have stayed till this point of time. Yeah. Okay. If you have any questions, you can just post it in the chat. Okay. The helpers will try to attend to you, and we can also send you into breakout rooms if you want. If you want to ask more questions about the workshop itself. Okay. Okay. So for that, this is the QR code for feedback form. So please send your feedback. We'll need to know how this workshop goes for each and every one of you. Yeah, so please scan this feedback form if you have no questions before leave. Okay. Yeah, before that, can I still promote this? Yeah, the Deep Learning Week. Okay, please sign up for Deep Learning Week if you have not done so. Yeah, so this is a very large event, and you get to know what are the industry partners that we're working with, and what's the extent of machine deep learning in the industry. Okay, these are so yeah, do remember to sign up for this event. And yeah, the workshops for these events are as follows. Okay, so this is the first one. You can follow us on Instagram, and yeah, if you want to attend these workshops, please feel free to do so. Yeah. Okay, so yeah, remember to give your feedback through this feedback form. Okay, thank you very much. Oh yeah, the recorded video will be sent.
We will post the recorded video on
Yeah.
YouTube, so you can stay tuned for our YouTube channel as well.
Yep. Yep. So the YouTube video will actually be uploaded when it's done. So yeah, after editing. Yep. A copy of the slides. Yeah, if you need the slides, then we can actually just send you the slides as well. The slides. Okay.